Hello students, in this video today we are going to solve the problems from question number 9 to question number 25 of exercise 13.1 of NCERT mathematics class 11. Okay, so in the last video I have already shown you how to solve from question number 1 to 8. Okay, if you haven't watched that video, so I have provided the link of that video in the description box, so please do watch that before it. Okay, so now the question number 9 is here. So here we need to find the limit of x tends to 0, here limit of ax plus b by cx plus 1. So here you can see this denominator cx plus 1 is not equal to 0 for x is equal to 0. Okay, so as x tends to 0, this denominator is not equal to 0, so that's why we can directly put the value x equal to 0. Okay, so in this case we can directly put 0 here. So that's gonna be b by 1, that is b. This is your answer. Okay, so now let me show you the next one. Okay, question number 10. Okay, so what is the question number 10 here? So here we need to find a limit. So let me write the solution here. Limit of z to the power 1 by 3 minus 1 by z to the power 1 by 6 minus 1 when z tends to 1. Okay, so we need to find it. Okay, for z is equal to 1, for z is equal to 1, this z to the power 1 by 6 minus 1 will be equal to 0 if you put here 1. Okay, 1 to the power 1 by 6 is 1, 1 minus 1 is 0, the denominator becomes 0, so that's why we cannot put here 1 directly. So what to do for in this case? So we need to simplify. So let us put z to the power 1 by 6 is equal to y. So we have put this one as y. Okay, so then we can if you square both sides, then what you will get? Z to the power 1 by 6, sorry, 1 by 6 into 2 y square, which implies z to the power 1 by 3 is equal to y square. So we have to replace z to the power 1 by 3 by y square and z to the power 1 by 6 by y. Okay, so now let's replace. So now here we will get limit of y square minus 1 by y minus 1. So here you see, here we have to write y tends to 1. So as you can see, when z tends to 1, sorry, let me write here. Okay, so as z tends to 1, y tends to 1. So if you put here z is equal to 1, then y will be also 1. Okay, so you can write like this: y tends to 1 as z tends to 1. Okay, so now you see limit y tends to 1. So y square minus 1 can be written as 1 square. So here we can apply a square minus b square formula, that is a plus b into a minus b, y plus 1 into y minus 1 by y minus 1. So here these two gone, so we can write now limit y plus 1, y tends to 1. Now we can replace y by 1. Okay, that's going to be 1 plus 1, that is equal to 2. That's our answer. Okay, that's how we can evaluate. Okay, hope you have understood this. Okay, now let's move on to next question. Okay, first let me clean this part. So our next question is question number 11. So here the question is, so let me write the solution here. Limit of ax square plus bx plus c, and the denominator is cx square plus bx plus a. Okay, here x tends to 1, so where a plus b plus c is not equal to 0. So here you see, if you put x is equal to 1, this denominator is not going to be equal to 0. Okay, that's why we can just put 1 here. Okay, a into 1 square plus b into 1 plus c. So here c into 1 plus b into 1 plus a. So here we will get a plus b plus c. Here we will get c plus b plus a. So a plus b plus c or c plus b plus a, same thing. So we can cancel these two. So that's why. So our result is 1. So that's our answer. Okay. Now next question is question number 12. So what to do here? Let me show you how to solve question number 12. Okay, so our question number 12 is limit of 1 by x plus 1 by 2 by x plus 2 when x tends to minus 2. Okay, so if you put here minus 2, this denominator becomes 0. Okay, so when denominator becomes 0, we cannot put the limit directly here. Okay, so that's why we need to simplify this. So how to simplify? First, let us simplify the numerator part first. Limit x tends to minus 2 here. So here LCM will be twice x, then 2 plus x it will be. So x plus 2. Okay, so here we can write this is equal to limit. So 2 plus x or x plus 2, same thing. So this twice x comes down, and x plus 2 we can write as x tends to minus 2. So here you can see x plus 2 gone. So we can write here limit 1 by twice x, x tends to minus 2. Now you can put minus 2 directly here. That will be 2 into minus 2. That's going to be 1 by minus 4, or minus 1 by 4 you can write simply. Okay, that's our answer. That's how we can solve question number 12. Okay, so now we have to solve question number 13. Okay, question number 13. So here clean this. Okay, now limit of sin ax by bx as x tends to 0. Okay, limit of this we need to find. Okay, so in this case what we can do here, we can write as so we know this standard limit. Here we have to apply standard limit of sin x by x when x tends to 0 is equal to 1. Okay, so if there is something, suppose if there is a, then here also in the denominator must also consist a. Okay, so let me write here clearly sin x by x. If there is sin x by x, then also when x tends to 0, that's equal to 1. Instead of only x, if there is suppose sin ax, then in the denominator here also ax. Okay, in that case also its value is 1. Okay, so here you say this is a, but this is b. This is sin ax, but here denominator, in the denominator it is bx, so that's why we need to make it a. So how to do that? So limit x tends to 0, here we can write a by b into sine ax by ax. Okay, so here you see, if you cancel a and multiply b and x, again you will get this. Okay, the first expression. Okay, so that's why we have to simplify like this. Okay, so we have already got this theorem that if limit of x, suppose when x tends to something, maybe h or something, okay, when k into fx is there, where fx is constant, sorry, k is constant, then we can write the limit like this: k into limit of f of x tends to h, whatever is the limit, doesn't matter. Okay, we can write like this. So here also we can write this one as a by b limit of sine ax by ax when x tends to 0. Okay, so in this case, here you say, now this part becomes equal to 0 according to standard limit. Okay, so here the answer is a by b only. So hope you have understood this. So now let's move on to the next question, that is question number 14. Okay, so first let me clean this part. So here you see, limit x tends to 0 sine ax by sine bx. So here what we're gonna do here, so here you can see limit, here we can write sine ax by ax, okay, then into bx by sine bx. Okay, in order to transform we can transform this into standard limits by writing like this. So here you see, now what to do, we have to multiply here a by b. Okay, because this part is not equal to this. Okay, so we have got here extra ax and bx, these two terms extra. So where you see, if you cancel this x, and if you cancel this a by a, this is b by b, then you will get this original expression. That's why we have to if you write in this form sine ax by ax, bx by sine bx, then you have to multiply here a by b. We have to multiply this term a by b in order to get the same expression. Okay, as given in the question. So why we have transformed this? Because we know the standard limit of sine x by x when x tends to 0, it is equal to 1. We are going to apply that. Okay, so that's why we have written like this. So what we can do now, so it is x tends to 0. Okay, so a by b can be written outside. So limit x tends to 0, and this expression can be written as sine ax by ax and bx by sine bx. Sorry, so if you write like this, then it will become sine bx by bx. Okay, so we can write this one as a denominator like in this form. Okay, so hope you have understood this. Sure. So you know, just it's a very simple thing. So if you have suppose a by b divided by c by d, we can write as like this: a by b into d by c, isn't it? So now compare this one with d by c. and in this step compare this one with c by d. Okay, hope you have understood this. That's very simple. So now what we can do, we have already got that. Let me scroll up this page. Okay, if you haven't noted, then just pause the video and note it. Okay, so we have already got that limit of two functions, suppose f of x by g of x, in this form when x tends to 0 or anything. Okay, any constant, suppose any number, suppose c may be there. Okay, then we can write limit of f of x tends to c by limit of g of x tends to c. Okay, we can write like this. So that's why in this case also we can write limit sine ax by ax when x tends to 0 divided by, we can write limit sine bx by bx when x tends to 0. Okay, so this is also equal to 1, this is also equal to 1. So here a by b will be 1 by into 1 by 1. Okay, that's equal to a by b. That is our answer. So hope you have understood this. So let's move on to next question. Okay, so our next question is question number 15. Okay, here limit x tends to pi, we need to find the limit of sine pi minus x by pi into pi minus x. Here you cannot put pi directly, because if you put x is equal to pi, then denominator becomes equal to 0, for which it will be not defined. So that's why we cannot put x is equal to pi in this case. So let us simplify by putting by replacing pi minus x by t. Okay, putting, or let us put, you can write putting this one. So here you see, as x tends to pi, then what will happen? If you put here pi, then t will be 0, isn't it? T tends to 0 as x tends to pi. Okay, t tends to 0 as x tends to pi. So that's why what we can do, so this limit we can write here, this is t by, and pi can be written as, if pi minus x is t, then pi will be t minus, as t plus x, or you can write x plus t, same thing. And here pi minus x is t, isn't it? So this is the expression. So here you see, sorry for this, let us do one thing, let us keep this pi as pi. Okay, as a constant. Pi is a constant, isn't it? Is 22 by 7. It has fixed value, or you can consider 180, whatever it is. If it is angle, then 180. If it's represented the circumference by diameter, then it is 22 by 7. Okay, now let us keep pi as a constant. Okay, and you can replace pi minus x by t. Okay, let us replace it by t. Okay, so pi into t. So t tends to 0. Here we have x tends to pi. So we know that as x tends to pi, t tends to 0. That's why we have to replace the x tends to pi by t tends to 0 as soon as we replaced pi minus x by t. So here you see, we can write this expression as 1 by pi into limit t tends to 0 here, sine t by t. Okay, sine t by t. So as pi is constant, so here we can write 1 by pi outside. So now this is becomes standard integral. So here its value is 1, so we can write 1 by pi only. So this is our answer. So hope you have understood this. So result of it is equal to 1. Okay, so our next question number 16 is limit of cos x pi minus x, so x tends to 0. So here you can put x is equal to 0 directly, because for x is equal to 0 denominator is not equal to 0 here, so that's why you can put 0 directly. So cos of 0 by pi minus 0, so cos of 0 is 1, so pi minus 0 is pi, so that is our result. It's simple as that. Okay, now 17, let me show you 17 here. So here limit of cos twice x minus 1 by cos x minus 1 as x tends to 0. So here you see, if you put x is equal to 0 here, cos 0 1 minus 1, this denominator becomes 0, for which it will be not defined. Okay, so that's why we have to simplify this one as well. So how to do that? Okay, so now you see, we know cos twice x. Okay, cos twice x is equal to 2 cos square x minus 1. Okay, now replace this cos twice x by this. Okay, so if you do so, then what will happen? So let me simplify here. Cos twice x minus 1, if you replace this one by 2 cos square x minus 1, then it will be 2 cos x square x minus 2. So you can take 2 common, cos square x minus 1. Okay, now that's why we can write limit here, we can write 2 into cos square x minus 1. Okay, so let me write it properly. Okay, so here cos x minus 1, limit x tends to 0. Okay, so now limit x tends to 0. Now this can be written as here you can apply a plus b into a minus b, a square minus b square formula, that is a plus b into a minus b, you can apply here. Okay, if you consider 1 as 1 square, then you can apply it. Then it will be cos x plus 1 into cos x minus 1. Okay, so here cos x minus 1, so you can cancel these two. Okay, then we have got limit 2 cos x plus 1, x tends to 0. Now you can replace the x by 0, and if you do so, then you will get cos 0 plus 1. Cos 0 is 1, so 1 plus 1, that's equal to 2 into 2, that's going to be equal to 4. So that's our answer. So hope you have understood. So now let's move on to question number 18. Okay, what is there? So let me clean this page first. Okay, okay, so this is question number 18. So what we can do here, this is the question, limit ax plus x cos x by b sin x, where x tends to 0. Okay, we cannot put sin 0 here in the denominator because it will be 0, then this is not going to be defined. Okay, so that's why we need to simplify this as well. Okay, so what to do? We can write this one as let us, here you see this is sin x. We know limit of sin x by x when x tends to 0, it is equal to 1. Okay, this is a standard limit. So that's why what we can do, let us multiply both the numerator and denominator by x. Okay, let us do that. What will happen? Okay, then limit x tends to 0. So here should not be written implies should not be written here, only equal sign. Okay, so if you divide both the numerator and denominator, you will get ax plus cos x by b sin x by x. Okay, now in this case we can write so sorry, here it is 0. Okay, in this case we can write limit of a plus cos x, x tends to 0, divided by limit b can be written outside as constant sine x by x, as x tends to 0, we can write like this. Okay, so here you can put x is equal to 0 equal to, so here a plus cos 0, so here b into 1, so this is standard limit, this result is 1 always. Okay, so cos 0 is 1, a plus 1 by b, so this is our result. So that's how we can solve question number 18. Okay, hope you have understood this. So now question number 19. Okay, now we have to solve question number 19. Okay, now let us solve question number 19. Okay, that is limit of x sec x, x tends to 0. So here you can put directly 0. Okay, 0 into sec 0, that's gonna be sec 0 is 1, 0 into 1 is 0. Okay, so that's our answer, it's very simple. So now let us solve question number 20. Okay, so 20, here you see limit sine ax plus bx by ax plus sine bx. Okay, when x tends to 0. Okay, so here also we need to apply this standard limit x tends to 0 when sine x by x, limit of sine x by x, x tends to 0 is equal to 1. Okay, we have to use this. So in order to use this, we have to transform these expressions in this form. Okay, so how to do that? First of all, let us divide both the numerator and denominator by x, and doing so we have got sine ax by x plus b and a plus sine bx by b. So in order to get this form, so if there is ax sine ax, so here also we need to have ax. So that's why what to do in the next step, we can write so let me do here. So you can write a into here ax. Okay, here also you can multiply b, and here also you can multiply, sorry, it's supposed to be x, isn't it? X. So here also you can multiply b. Okay, so you can do that in order to obtain this form. Okay, so now here you see there is ax, here is also x, here it is sine bx, so denominator is also bx. Okay, now what we can do, we can write here a limit of sine ax by ax, x tends to 0. Okay, plus, so this is b is constant, so limit of constant is nothing but it is constant, isn't it? So we can write simply b. So here also limit of a when x tends to 0 will be again a, it is constant. So here we can write b into limit x tends to 0, here limit of sine bx by bx. Okay, so value of these two is equal to 1. So what we can do, we can write a into 1 plus b, and here we have got a plus b into 1. Okay, that's equal to a plus b by a plus b, which gives 1. Okay, if you cancel numerator and denominator, you get 1. So that is our answer. So hope you have understood this. Now let us solve question number 21. Okay, so here is the question, limit of cosec x minus cot x where x tends to 0. So you know 1 by cosec is cosec is 1 by sin x, and cot is nothing but cos x by sin x. Okay, so taking LCM, it's becomes sin x, here numerator becomes 1 minus cos x. So you can replace this term by this one. Okay, so let us do a bit. So it will be 1 minus cos x by sin x. Okay, then here you see we know this trigonometric identity. This 1 minus cos twice a is equal to 2 sin square a. Okay, 2 sin square a. So if you replace this twice a by x, okay, if you replace this twice a by x, if twice a is equal to x, then a must be x by 2. Okay, so then that's why we can write limit here x tends to 0. 1 minus cos x can be replaced by 2 sin square x by 2. Okay, sin square x by 2. And the sin x, so if you consider sin x as here we are going to apply sin twice a formula, that is 2 sin a cos a. Okay, now replace the twice a by x by 2, sorry, not x by 2, sorry, x. This replace this twice a by x, then a must be replaced by x by 2, isn't it? So then we get here 2 sin x by 2 cos x by 2. Okay, so here 2 will be cancelled, then sin x by 2 will cancel with sin square x by 2. So we will get limit x 0. So in the numerator we have now sin x by 2 and here cos x by 2, which gives limit x tends to 0. Sin by cos is nothing but 10 x by 2. Okay, 10 x by 2. Okay, let me clean this part. Okay, so now what will be the result of this limit? Okay, we know tan 0 is 0, so here you can put directly 0. Okay, so let us put 0 here. Tan, it will be tan 0 by 2 is 0, tan 0 is 0. So that's the answer of this question. Now let us solve question number 23. Sorry, 22, not 23. So here you can see question is this: limit of tan twice x by x minus pi by 2, x tends to pi by 2. Okay, so here you cannot replace the x by pi by 2 directly, so because denominator is going to be equal to 0. If so, then this will be not defined, so that's why we have to simplify this. Okay, so let us put x minus pi by 2 is equal to y. Then you see here y tends to 0 as x tends to pi by 2. So if you replace the x by pi by 2, then y will be equal to 0. Okay, that's why we can write y tends to 0 as x tends to pi by 2. So in this case, what we can do, we can write the limit as, so tan twice x, instead of twice x, here we can replace this by so if x is equal to, so now you see we have taken x minus pi by 2 as y, so x will be equal to y plus pi by 2. Okay, then twice x will be equal to twice y into 2, that's going to be twice y plus pi. Okay, so that's what we have got. So we can write like this, tan twice x can be written like this: tan 2 into pi by 2 plus y. Okay, we can write like this, pi by 2 plus y, or let me write directly like this. Okay, that is y plus pi, twice y plus pi. Okay, or pi plus twice y, same thing. So let me write pi plus twice y. Pi plus twice y, and here it is y, sorry, y tends to 0. So that's what we can do. Okay, so now you see this is twice pi, sorry pi, this is pi, and pi plus something is in this quadrant, so it remains positive, and pi means 2 into pi by 2, so even multiple of pi by 2 remains, if there is 10 then 10 remains 10, so we can write like this, limit 10 twice y by y, where y tends to 0. Okay, so we can keep it like this. Then what you can do in this case, so this is y, so there is a standard limit x tends to 0, limit of 10x by x, okay, when x tends to 0 is 1. Okay, so this is standard limit. So if there is twice x, then there must be also twice x. Okay, so instead of x there is y. Okay, so what we can do here, if you make it twice y, then you have to multiply 2 here. Okay, then what we can do, let me clean this side. Okay, so next we can write 2 limit of 10 twice y by twice y tends to 0. Okay, y tends to 0, that's why 2 into, and value of this part is 1, so that's why it is 1, 2 1s are 2. So this is our answer. That's how we can solve question number 22. So 23, so here we have f of x, this is the function which is equal to twice x plus 3 when x is less than equal to 0, and thrice x plus 1 which where x when x is greater than 0. So here we need to calculate limit, we need to calculate limit of fx when x tends to 0 and limit of fx when x tends to 1. We need to evaluate these two. Okay, so how to do that? In this case, here you see we have two conditions here and two different results for two different conditions. So greater than 0, less than 0, that means we have to evaluate it from both sides. Okay, so that means from the negative left hand side and from the positive side, that means right hand side also. Okay, so let's do it. So first let us find left hand right limit of fx when x tends to 0, negative means left hand limit. Okay, left hand limit. So for x less than 0, the result is limit twice x plus 3. So x tends to 0, negative, this is left hand limit. Okay, so then if you put here 0, you will get 2 into 0 plus 3, that's going to be 3. And let us evaluate from right hand limit, x tends to 0 positive, so f of x. So here for greater than 0 value we have this. Okay, so that's why limit we have 3 into x plus 1, x tends to 0 positive, which is going to be equal to 3 into 0 plus 1, that's going to be equal to 3. Okay, therefore we have got both the left hand and right hand limit equal, so therefore limit of this function exists. Okay, so limit of f left hand limit, right hand limit, both equal to 3, that's why we can write limit of f of x tends to 0 is equal to 3. Okay, so hope you have got this. So now let us find this one, evaluate this one when x tends to 1. So now we are going to evaluate this. X tends to 1. 1 is, you see, 1 is greater than 0. Okay, so that means we need to calculate this only, we need to work on this part only. So that's why limit f of x tends to 1 is equal to limit thrice x plus 1 when x tends to 1 is equal to 3 into 1 plus 1, that's going to be 3 into 2, that's going to be 6. Okay, so that's our result. So hope you have understood this. So how to find this 6. Now let us solve 24. Here we need to find limit of f of x tends to 1. We need to find this, where f of x is equal to, this function is equal to x square minus 1 when x is less than equal to 1, and it is minus x minus 1, sorry, yes, no bracket, minus x square minus 1 when x is greater than 1. Okay, so here you see we need to find x tends to we need to find a limit for x tends to 1. So here it is given there are two different results for left hand limit and right hand limit, x greater than 1 and x less than equal to 1. So that's why we need to calculate from both sides. So limit x tends to 1 negative means left hand limit here of fx. Here we can take limit for left hand limit, we have x minus 1, x square minus 1, not x minus 1, x tends to 1 negative. So if you put 1 here, 1 square minus 1, that's going to be equal to 0. Okay, now let us find from the other side, that is right hand limit, x tends to 1 positive. Okay, x tends to 1 positive. So limit for 1 positive, that means x greater than 1, we have minus x square minus 1. Okay, so when x tends to 1 positive, so minus 1 square 1, that's going to be minus 2. So here you see we have got different results. Here left hand limit and right hand limit are not equal, since limit x tends to 1 negative of fx is not equal to limit of fx when x tends to 1 positive. So these two limits are not equal, that's why this limit doesn't exist. Therefore limit of f of x when x tends to 1 does not exist. Okay, so here you see we need to evaluate limit of f of x for x tends to 0. Okay, we need to evaluate this. So here f of x is given, f of x is equal to mod of x by x when x is not equal to 0. Okay, and it is 0 when x is equal to 0. Okay, so we need to calculate this from both side, left hand limit and right hand limit. Okay, so let's do it. So now here you see limit x tends to 0 negative means left hand limit of fx, that is limit when x is not equal to 0. Okay, so here what we have got, this is so that's gonna be equal to, if x is less than 0, then here we have to write minus x by x, isn't it? So x tends to 0 negative, so here it will be minus 1. Okay, here it will be minus 1. Okay, if you cancel these two, this one will be minus 1. So limit of fx, x tends to 0 positive. Okay, that means from the right hand limit. So x tends to 0 positive, so here we have to write this mod x by x. So for right hand limit x greater than 0, so this x mod x should be replaced by positive x. So here x tends to 0 positive, so here it will be plus 1. So as you can see, both the results are not same. Here different results we are getting. So that's why I don't think that limit does exist. Okay, actually limit doesn't exist in this case. So limit of f of x, x tends to 0 negative, is not equal to limit f of x, x tends to 0 positive. Okay, that is why Therefore you can see that limit of f of x tends to 0 does not exist. So then we have more questions in this exercise. We will solve the remaining problems in the next video. So if you like my video, then please subscribe the channel and please inspire me to create new contents for you. Okay, so hit the thumbs up button and share my videos, and also hit the bell icon as well, so you get notifications when I upload new videos. Okay, thank you for watching.